And welcome back. Now this week, yes, you're going to get a double whammy because there's really two videos in one. Now I can understand if some of you do not want to know about HTTP 1.1 on the BBC and why it went wrong and why now it's working and all that. So if you really don't want to watch that, perhaps you want to watch the second half of the video, which is all about this little beauty down here, the Pico, Raspberry Pi Pico. Yes, it does work on the Arduino IDE, and I'll show you very quickly how to set that up and get it working. Now it runs in both Arduino Classic, that's the original IDE that, you know, is little more than Notepad, and the new Arduino 2.0, right, which is obviously a lot better, and it works in that as well, with a caveat or two. But it'd be a pity not to understand why this went wrong and why it's now fixed, wouldn't it? So stay tuned. Okay, after this quick message, I've got some bills to pay. A quick shout out to PCBWay, and things have been happening there. First of all, you can still get your PCBs for $5 for 10 pieces, and the turnaround time is anything from 24 hours upwards. And don't forget that if you want some SMT soldering done on your behalf, it's $30 for up to 20 pieces. Great for those prototype runs. But there's more, much more at PCBWay just now. If you notice at the top of their webpage, you'll see the CNC 3D printing menu selection. Look at this, they do 3D printing, CNC machining, sheet metal fabrication and injection molding. The list goes on and on. Let's have a quick look at that page. So here on the 3D printing page, you can see the parameters that you need to specify, as well as your CAD drawings. And similarly, you can go to the CNC machining page, the sheet metal bending and cutting, and finally the injection molding. I tell you, the sky's the limit. Oh look, they've got a Raspberry Pi Pico contest. Now there's an interesting thing. Let's have a quick look at that webpage, shall we? So here's the PCBWay Raspberry Pi Pico contest. What they're suggesting is that you can either get a Raspberry Pi Pico from their gift shop and make your project, or if you've already got one, submit your project, and the best of luck. I tell you, the sky's the limit. More details available from the PCBWay website. Go and have a look now. Right, first of all, let's put a nail in the coffin on this whole ESP32 saga regarding the BBC URLs, which, as you know, half of them stopped working on March the 21st. And even when we'd extracted the new BBC URLs, loads of people found burbles and chirps, and basically is unplayable. Now, my resolution to that particular problem was taken from the guidance of the comments on screen from somebody. You look at last week's video, the week before that, it's all in there. But basically, we said, right, stop using HTTP 1.1, we're going to use HTTP 1.0. And then all things sprang into life again, and everything was pretty good. But I said, well, I'm going to dig deeper and find out why I can use 1.1 with everybody else, and it's just the BBC that does it wrong. Okay, technically, I agree. The BBC are not doing it wrong, but they are doing it differently than everybody else. Or perhaps they're just going by the absolute letter of the book, if you like, the standards book, and doing it right where everybody else is doing it wrong. Whatever, they are doing it differently. And if I were a cynical man, it's almost a case of, well, I wonder if they're doing it this way because they know that loads of internet radios cannot handle this stream and therefore cannot be used, and therefore the amount of people connected to their servers is going to drop like a stone, so they can say, ha, nobody's using it, we can switch it off. But I wouldn't say that because I'm not that cynical. Right, let me just first of all bring up the debugging screen of the code that's running on here at the moment, because I want to show you just a couple of lines on it, and it'll make all things clear. So this is the debugging screen. Okay, I'm using CoolTerm, right, which I've mentioned to you before. Absolutely excellent. I've been talking to Roger, who makes this in his own time. He's just a hobbyist like you and me, but it's a really great program now, and he's put some nice features in there. We've had a little discourse via email, and he's taken on board some of the things I suggested, and he's put stuff in as well, and it really works well. I'm going to put a link to my to the code underneath here. It's freeware, but like freeware, I mean, if you think this is worth the price of a cup of coffee, you know, or two, please donate. I find it much more easy to use this than say the inbuilt serial monitor of the Arduino or even Platform.io, frankly, because it's a separate piece of code, isn't it? You can run this separately somewhere, not built into the IDE. Let's just let me just tune into a station, and you'll see what I mean about this resolution at an instant. Right, first thing to do then is to tune into a new station, which we do by, I'm going to do this via the camera, so it's going to be right cack-handed. Let's have a look. Oh, well, okay, let's go to Planet Rock. Okay, you're not going to hear anything, but I do want you to see stuff. Okay, right, let's get that this back here again. Right, so it's connected and it's running, but I just want to scroll back up. Now, as I said before, oh, this is one of the things that Roger's thing's done. As can you see down there, it now says display paused because I scrolled back up. Look, it automatically pauses. Have you ever had it with a scrolling screen where you're trying to scroll back up, but it keeps putting stuff at the bottom of the screen and forcing you down to the bottom of the screen? See, it doesn't do that. It stops and it's put it in there that, you know, I've paused the display for you. Right. Remember that I said I've corrected the problem and I've always used HTTP 1.1 in all my connections up until we had the problem with the BBC. And just a couple of days ago, frankly, I thought, well, surely it can't be as simple as this. Look, these are the headers. The headers. It says header, right? Big clue there. So basically, you connect to a URL, the station. You go, oi, station, I'm connecting to you with HTTP 1.1, and I want this particular path, which is the music streaming path. And it goes, okay, I'm here. I'm a header, HTTP. There's my bit rate and the IC publishing and all other stuff. Oh, hang on just a minute. We went too fast. HTTP 1.0, but I've said I'm running in HTTP 1.1. Every single radio station, apart from the BBC, even though you try and connect with HTTP 1.1, responds with HTTP 1.0. So whether you connect with 1.0 or 1.1, you'll get a connection of 1.0, which means, okay, so if you're connecting to the BBC with 1.0, you get a response of 1.0, as you should. When you connect with HTTP 1.1, you get a response of 1.1. And what's the big difference? Well, I'm going to have to connect to the BBC and I'll show you. Here we are, BBC Radio 4, connect, and let's go back to the debugging window and scroll down because we paused. Right, let's go back up to where it connected. So what you can see here then is HTTP 1.1. We've got a 200 response, which means okay, fine, it means okay. So it is connecting HTTP 1.1. All right, so what you're thinking, does it make any difference? Yes, it does. It makes a huge difference. One of the things that HTTP 1.1 gave us was something called chunking. Yeah, I know. Basically, as it sounds, HTTP 1.1 says, right, okay, I can give you chunks of data. That's the real technical word for it, chunks. All right, so it goes, I'm going to give you a chunk of data, but the first few bytes of that chunk will tell you how long that chunk is. So you've got to start reading the chunk byte by byte until you hit a carriage return line feed pair of characters, and those previous characters you've read are in ASCII and they represent the hexadecimal value of the amount of data that's coming down in this chunk. Hang on, you're saying, do you what? Hexadecimal ASCII, what? Yeah, I know, believe me, it was mind-bending. So basically what the BBC are doing in HTTP 1.1 mode is going, right, I'm sending you down some ASCII characters that represent the characters, the string characters, 1, 0, 0, 0, carriage return, line feed. So by extracting those characters out as a string, and it's 1, 0, 0, 0, that is now hexadecimal. So you convert that string that represents hexadecimal value, and you convert it to decimal, and it's 4096. Okay, so you can read 4096 bytes, not including the terminating carriage return line feed characters after that, 2 of them. And it goes, right, that's one chunk. Now I'm going to give you another chunk. So start off with the ASCII characters, and it might not be 1000, it could be any value. Okay, so what's happening here, let me just highlight the bit. Look, this is the key bit, transfer encoding chunked. All right, you will never get that on a 1.0 because it wasn't around in 1.0. It's the new feature. So I've detected that here, and I go, ah, right, you're chunked. And off it goes. And, oh, look, I've got some errors. Couldn't read a chunked byte. That means the stream's too slow, basically. But if I scroll back up, you'll see that it's working fine. In fact, if I increase the volume, we should see it to playing Radio 4, which we hope we get away with, don't we, for you know, the copyright stuff.
The accident in Silla province in the south of the country killed at least 30 people.
Okay, that's an unfortunate bit of news, but yeah.
Toppled a statue in Egerton Rise.
Right, okay, that's enough. But you heard that it's streaming absolutely fine because I've now got these chunks of data that I'm throwing into the circular buffer once I've stripped off the header and the trailer of the carriage return line feed. So it's all working fine. How does that help anybody who's taken my code? Well, in Platform IO, it's all working great. In Arduino, I haven't even moved this code over to Arduino Speak. I say Arduino Speak, it's ESP32, but running on the Arduino IDE, it's a bit different. I will do in the future, but not just quite yet. And I've changed my code back to always having HTTP 1.1 because I can cope. Except if a commercial radio station suddenly decided, oh yeah, we will support HTTP 1.1 actually with chunked data and metadata, disaster, because I've not written my code to cope with metadata and chunked data. And I haven't even looked at it because metadata is already embedded in that data. So we've got chunked data with metadata all bedded in. And I'm thinking, do you know what? I'm not even going to go there. The BBC do not send down meaningful metadata, that being the title of the track, artist and things like that. It just says BBC Radio 4 or BBC Radio 2 or whatever. It doesn't give you any indication of what's actually playing. So I thought, well, in that case, there's no point in having metadata, is there? So in my radio station, I've said I'll connect to Radio 2 or 4 or whatever it is, but I do not want metadata. So I'll put a 0 at the end of that station list. Quite important that. Let's hope they don't say, yes, I will give you metadata in a true 1.1 chunked data stream, because that would mean even more code development. I just don't want to go there. I thought I'd finish this thing. Yeah, I know, never finishes, does it? Okay, what else have I got to tell you? So I mentioned that I've got this running now on the Arduino IDE. It wasn't that difficult. People have been there before me and they've got it all working. But having done that and got this running on C++, as you can see, there's the ubiquitous flashing LED on there. Yeah, that's all very good. And of course it does start instantly with no delay because it's just pure C++ on here. No bootloader, no nothing, no interpreter. Does that mean then we can just take our Arduino sketches and compile them and plonk them on here? No, it doesn't. No, not by a long shot. Not by a long shot. When you think about it, yeah, on here, although we have multiple I2C pins that we can use, I think I was using a couple over here, 5 and 6, I think it might have been. GPIO pins 5 and 6 and all that. There's a couple more at the front here. With the Pico, you have to tell it, A, which pins you're using and set this all up ready for things like I2C. All right, because I was hoping to get this running for you today. This is a very simple I2C 16 by 2 character display, and I use them all the time. You know, very easy to use normally, but of course, what's the thing we always use in the Arduino world? Libraries. How on earth are those traditional libraries for the classic Arduino IDE ever going to work on something like this? It's got a totally different pin out. Yes, I know there will be a pin definition file as part of this board definition for the Arduino, but of course those libraries have probably got the things hard coded, haven't they? After all, I2C was always on pins and yeah, was it A4, A5? Yeah, A4, A5. It just doesn't apply to this. So those old libraries will not work, and I suspect in the fullness of time, if not already, there will be some other libraries. But you know, it's not that difficult to get I2C, for example, working natively now using the C++ that we have available to us. But that's a little bit in the future, isn't it? What I want to get for you today is to say, right, how do I get this board running on the Arduino IDE, either the classic or the 2.0 new one, right, which I strongly recommend, but I had to use the classic first, and I'll tell you why as we go through. Okay, step one, let's start. The first thing we've got to do to get this working on the Arduino IDE, whichever variant you use, is say hello to Earle F. Philhower, the third, no less. Yes, he's one of these people who has a brain the size of a planet and he's done loads of stuff. But today, the thing we're looking at is this. Now, what he's done is ported the C++ library, or the platform, I suppose, the framework, to the PICO. So let's just scroll down and have a quick look at that. So this is the README on that file. Don't worry, you won't have to actually implement this yourself. It's all now built into the Arduino IDE. So let's just scroll down a bit more. And it tells you how to install it. Okay, so you can either read this, I'll put the links obviously down below, but I'll show you how to do that as well. So here's the Arduino IDE Classic, as we'll call it. I think this is version 1.813. Yeah, it is. I don't know if there's a higher version or not, but anyway, you can see the code there. That's actually running on that PICO right now. But how do we get this code to compile? How does it even know about the board? As you can see down here, there's some interesting information that we don't normally see as part of the Arduino world. Right, first of all, go to File, Preferences. Just click that on the drop-down tool list, and you'll see this thing pop up. Now, you've probably already done this, but if not, here's your chance to learn. If you're not going to use the standard Arduino boards as supplied by Arduino themselves, you know, third-party boards, ESP8266s, ESP32s, STM32s, feather boards from Adafruit, anything like that, you will need to edit this line here, because this tells the Arduino system where it can find definitions of those external third-party boards. Don't edit it directly in that line. Click this little thing on the side here, because that'll bring up a little text box, which you then should expand to the right so it doesn't overflow. There we are, look. So now you can see I've got quite a few in there, but the one we're interested in is this last one here. Don't worry, this is both in that GitHub page that I showed you, you can look at, or I'll put it into the video description. You simply put that in here and click OK, and then OK again. So you've now added in that line which tells Arduino, or the Arduino IDE, where it can go and find some boards. Is that enough? No, of course it isn't. You now have to go to Tools, Board Manager. You see this bit here where it says Board Manager? Yes, I've already pre-selected Raspberry Pi Pico because I've done this, haven't I? Go to Boards Manager and click that. Now give it a while. Just hold your horses, stop clicking, get your hands off that button there. Look, down the bottom here, it's downloading stuff now. All those lines that you saw in my particular third-party board list, it's quite long and it's downloading it. Done now, look, there we are, look, it's done. Now, what you need to type in here, you can either scroll down and find it, of course, but if you type in Pico, now, on this one it says don't use this one here, don't use that one because that's the Arduino actual board, you know, with the Wi-Fi and all that. That's the one there, look. I'll zoom in on here, but this is the Raspberry Pi Pico RP2040 by Earle F. Philhower III. Go down to here. You won't see an update button, you'll see an install button and then various versions, right? So he's obviously been doing this for quite some time, look. And the latest version is 1.81. Oh, look, there's some newer versions. Look at that. 1.82 and 1.83. Well, obviously, I'm going to update to 1.83. Why wouldn't I? Because I'm running on an old version. This is only a couple of days ago that I installed this. So let's click Update. Pretend you're clicking Install instead. And it says down here, look, it's downloading stuff and it's installing over here. So it's a busy little thing, yeah. And oh, look, there we go, whizzing down. Yes, I might live in the middle of a field, but I do have 66 to 67 megabits per second download speed when the internet's working properly. Multiple interruptions per day, usually. Yesterday being a Sunday, no interruptions at all. I was tuned into the ESP32 web radio I have here all day. Not a single interruption to my music. So it just goes to show, doesn't it? Somebody's doing something in the exchange or something. Anyway, this is installing now, as you can see. It's pretty quick. I know I'm waffling on here to fill the time rather than cut the video, but it is pretty quick. There are installation successful, it says. Oh, completed, in fact, it says. There we are, done. So now we can close that. Okay, and from then on, when you go to tools, that's another thing, you have to wait a little bit before you can click on the tools as well. Go to here, and then you can see all the boards that you can possibly install. The one we're interested in, I know I've pre-selected it, Raspberry Pi 2040 boards, look, and it says which ones do you want. There's all these, right? Well, obviously we want the Raspberry Pi Pico, which I've already got, but you can obviously select any one of these RP2040 boards. So that's great. So I'm selecting Raspberry Pi Pico. Now, there's a few little parameters on here you need to be aware of. Having selected the board, you need to tell it a little bit more about your particular board. What have you actually got? So go back to Tools, and down here, and it says flash size. Now this goes back again to how much memory of the memory on that chip do you want as flash memory for your program. How much memory do you want to put aside for EEPROM or stuff you can use little FS with, right? And we've covered all that. I don't want to get into it again today, but here you can say how you want to split that memory up. Okay, I'm not going there today. Leave it as 2 meg, no file store, right? Just it's all available to your memory, even though we're not going to use hardly any of it. Now, CPU speed, that one there, I was a little bit confused about this because you remember last week or the week before, whenever it was, I said it's 133 megahertz, that chip, dual core, 133, but it comes up as 125 as default. And I think, so that means we can run it as 125, but I would have personally liked to have selected 133. But if I do that, it might mean that the UART and all that isn't quite synced, or the USB isn't synced. So I've just left it as is, and it's all been working fine. But I will be looking into that, why we have these other options. I mean, 50 megahertz, that's quite a down turn in speed there, isn't it? And it says you can overclock it. I've not tried any of that. On your own heads be it. If you overclock it and then it doesn't work, I don't know how you get around that. Debug port we're leaving as disabled for now, and the debug level is none for now. I want to look into the debugging on here because you can do single wire debugging apparently. That would be really good. That, in fact, if you could do single wire debugging on here but treat this as a nano, it would pretty much be enough to tip me over the edge and think, yeah, this is a chip I want to use, because it just makes debugging so much easier. No more serial print statements everywhere you need them. Oh. Yeah, I know. Anyway, USB stack, well, I've left it at the Pico SDK, right? Software development kit. There is the Adafruit tiny USB, don't know what the difference is, I haven't gone there. And the port, now on here, oh yeah, forget COM5, that's my video switching thing. COM8, Raspberry Pi Pico. Now COM8 comes and goes, if you like, as you upload and download programs, but when you plug it in initially, it should give you a COM port, right? And COM port I've selected as 8. You can even get the board info, because I've plugged it in, it knows where it is. If I click that one, it says, there we are, Raspberry Pi Pico, the VID, the PID, and the serial number even. So we've done that then. We've now told the Arduino Classic IDE, that's what I want to do. The end. We don't have to do that again unless you change your board. Now, the other thing is, when we first run or try to upload a program to the Pico, they say you have to take this cable out, press the boot select button, and then while it's pressed, plug this back in so it goes into bootloader mode and stays there. Now obviously I've got this little reset button that Pimmer sent me. It was £1.50, and the pound gets donated to the Raspberry Pi organisation or foundation, which I think is a good way to support them, isn't it, really? So I don't need to do that. I can just press the reset, hold that, then let go of the reset, and it's into that mode. Last week, whenever it was I was talking about using Python, MicroPython, and the interpreter was downloaded onto here first, there were a few questions in the comments like, if I go the MicroPython route and it's downloaded the interpreter and then decide, no, that's not for me, I want to use it in Arduino mode, how do I know I'm not using up memory with the MicroPython stuff? How do I basically blitz it like it was out of the factory? Very, very easy. Do you remember last week I said when this goes into bootloader mode, it comes up as a drive letter in Windows. And I'm sure it'll be similar in Mac and Linux, but I'm not familiar with those, so I can't tell you, but it must be similar to that. Let me show you what I mean, and then it's a 2-second job to blitz that flash memory on there. Right, I've got up File Explorer just to show you that this becomes effectively like a USB stick when we put it into bootloader mode. And I've moved things around so you can see what's happening. So that's Windows Explorer there, showing you the drives that are on my machine at the moment, and there's no H drive, which is what this comes up as. So let me just reset it, and excuse my fat fingers. Yeah. Okay, let's get this out of the way. This nail of mine that everybody keeps commenting on, and you can see it's pretty damaged and mucked about with. Yes, I jammed something underneath that nail while I was creating this workshop. It bled quite a lot. Of course, it didn't hurt at all. And I said something like, oops and ouch. I think that's what I said anyway. And that's what it turned into. So you've got this sort of distorted nail, gone all black, but it's slowly growing out. Okay, so no more comments about my nail, please. Thank you very much. Right, we're going to press the reset button on here, press the boot cell, let go of the reset, let go of the boot cell. There we are. Look, almost instantly, that Raspberry Pi RP2 H drive appeared. So we'll open that up. And these two files are always in there. That one takes you off to the internet. And that one just is a little bit of information about what's on that chip. Now I'm going to drag in a file called Flash Nuke UF2. All the files that are uploaded to this chip, by the way, are all in UF2 format, which is some Microsoft USB stick type file format. Look it up on Wikipedia if they're interested. Yeah, Flash Nuke UF2. So I'm going to drag that. I'm dropping it. There it is. You just saw it. Now, if you notice on here, the flashing of that LED stopped. Yeah. So let's get rid of that window there. So this is now factory fresh as it came out of the factory. Yeah. So the code that was on there is gone. The MicroPython interpreter is gone. That flash is gone. All right. Now that Flash Nuke UF2 program, I think it was on the Adafruit website. Wherever it was, I'll put a link to it. All right, so you can find it. Just make a copy of it, download it onto your machine, and keep it handy. Because if you ever get into a mess with this, where it's not responding right, or you've totally buggered something up, basically, use that Flash Nuke UF2, and you'll bring it back to this state. Cool. Okay, so what we've done so far then, we've got a factory fresh Pico. We've got the classic IDE Arduino running, and I've got some code on there as well. And there it is. So let's just, all it is a double flash, right? There's nothing, we're not going to go through the code and nothing, no way. I'm using the built-in LED. I can make this a little bit bigger for you though. Okay, it's a little bit bigger. Right, so I'm using the built-in LED that I've defined up here as pin 25. And it just, well, as you can see, this is all standard Arduino speak. Yeah, I know, the disappointment will come later. I'm just flashing it a couple of times. All right, it's just a blink program. So we can upload that. Now remember, this is now sitting, well, it's not really on a port or anything really. So let's see what happens then. Okay, this is the first time, as far as that Pico is concerned, we're uploading this. So let's compile and upload. And I'm definitely going to speed this bit of the video up because it still takes forever. Oh look, something's happening, long last. Now what you can see here is it's using the packages from the RP2040 that's been installed in my local app data, which I don't like at all. I like to keep control of where stuff's being installed, but there we are. Right, so it's compiled it finally, the Blink program. Now it's trying to find the Pico. Yeah, and as you can see, nothing's uploaded yet, no flashing LED on there yet. Oh, look, it says it reset COM8. It converted the file to UF2 and it wrote it, it says. And what have we got on there now? Oh yes, we've got the ubiquitous flashing LED. Now, the very, very, very first time I had to do this, I tried it on the Arduino IDE 2.0. It didn't do this. It wouldn't work. It goes, no, can't find it, can't do it. No matter how many times I pressed that and combinations thereof and plugged it in and out, wouldn't do it. Came to here, worked first time. So just for the sake of it, for giggles and laughs, we're going to switch over to Arduino IDE 2.0 Beta 6. Right, I've switched over to the Arduino IDE 2.0 Beta 6, which is what you can see on screen there, the code. I've moved this into position so we can change the code. Now, as you can see there from last night or whatever, I've already uploaded this once, but not today. All right, so what I want to do is stop it flashing that LED there and make it flash this external one here, which I've put on GPIO 16, which is the same bit of code you just saw, but I've changed the LED here to EXT LED. Okay, and I think it might flash it a bit quicker or something. Whatever. It's just a very simple blink program. So if I clear this, can I clear it? Clear output, it says here. Doesn't show on screen. Right. Okay. So let's upload this and just see what happens, if it works or not. I don't know. It's all good experience, isn't it? Oh dear. Oh look, upload failed, it says. Did we actually manage to compile it? That's the question. Let's compile it first. Let's use that button there. No, it was the compile that failed, not the upload. Okay, what's it failed on? Raspberry Pi at COM8. Yes. Well, the long and short of it is I don't know why it's failed, especially as it's helpfully telling me it's got an error 2, which is unknown, and it's just thrown a wobbly. So what I'm going to do is shut it down, relaunch it, because it's been sitting here for a little while now, you know, a full 24 hours on my desk, and see what happens, shall we? Okay, I've relaunched it. I haven't tried uploading, so well, let's try compiling first. Let's see if it'll, as it says up there, verifying. Yeah. See what happens. Oh, seems to have gone a bit further this time, because as we know, the blink sketch is particularly onerous on the compiler. I have no idea. Well, it's beta software, isn't it? I mean, you know, you can't really say too much while it's beta. Of course, once Arduino release this properly as 2.0, then they'll deserve all the flack they get. Right, okay, it's compiled the blink program. Woohoo! But the old one, if you notice down here, look, we haven't uploaded anything yet. The old one's still running the old blink program on the internal LED. So let's upload that and see if that works. I'm a little bit disappointed it's still compiling everything. You think it would know whether things have changed. Certainly my old Eclipse Slober version knew that. So it's waiting for the port, but there won't be an upload port. So it's falling back to COM8, as it says down here. And hopefully it will find something. If it doesn't, we'll have to press the old reset button, I guess. Oh, there we are. Look at that. And this LED is now double blinking, and that one has stopped. So yes, it has uploaded. It is a little bit irksome that it takes so long to figure all this out. It goes, I'm looking for the upload port, can't find one. It was on COM8, so I'll reset that so that this goes into bootloader mode. That then takes a long while for it to sort of handshake, I guess, and then eventually it uploads. If you're uploading often, that will become quickly very irksome. And it takes that long, whether you're doing it in the beta IDE or the old one. It's just that handshake thing. I'd love to get hold of a proper Arduino Nano RP2040 to see if it's any difference, but it's frankly too much money for me at the moment. So yeah, okay, so there we are. So it works. Once you've installed that framework from Earle, which is that port of the C++, things go swimmingly to a degree. Well, they go swimmingly as far as simple things like this go, right? When I tried to then put a very simple sketch in here that talked to that I2C library to control this, there was obviously no joy, and after a while you just think, well, of course it can't work, can it? So I'm wondering who's going to write the first library for something like this. So I'll investigate a little bit further, because I need to know exactly how difficult it's going to be for us Arduinoites going forward. But for now, I'll leave you with all that. Yes. And in the meantime, you can go and have a look at the links in the video down below for this. Download that C++ framework and get yourselves running. In the meantime, if you like this video, give it the old thumbs up. Put your comments and questions and everything else down below. And see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.